Hi, I'm Ricardo Torquato from the University of Campinas in Brazil, and I'm here to present this work, Impact Assessment of High-Frequency Distortions Produced by PV Inverters, which was presented on the IEEE Transactions on Power Delivery Journal. So, PV inverters inject distortions at high frequencies, usually around tens of kilohertz. And it's important to analyze these distortions and investigate their characteristics because they are different from traditional distortions that are injected at frequencies below 3 kilohertz usually. This work investigates the emission and propagation characteristics of these distortions. And this investigation is carried out in three different levels. First, at device level, where we analyze how these distortions are created and injected into the network. Then at house level, that we investigate how these distortions propagate within a house. And finally at grid level, where we analyze how these distortions propagate into the grid, into the low voltage and medium voltage grid. So starting with the device level, our main finding here is that these PV inverter bridges, their behavior is more or less close to a voltage source behind the front-end filter of the inverter. This front-end filter is simply a passive component with inductances, capacitances, and so the main important point is that here the inverter bridge operates as a voltage source. This is important because it's different from traditional harmonic generators which behave like current sources. So this is the first finding that is different from traditional sources, and it's important to know this because it affects how they behave on the network. The other important thing that we investigated, that is the house level propagation, how these distortions propagate inside the house. And in this case, we conducted a field experiment where we had a customer with a PV generator. And when measuring the emissions of this PV generator and then measuring which portion of these emissions were injected into the grid, we found that we had two experiments. On the first one, about 79 to 80% of the emissions were penetrated into the grid. And on the second experiment, only 30% of the emissions penetrated into the grid. And the difference between these two experiments is which loads were connected into the house. So the finding here is that the characteristics of the loads in the house, they can help sink part of these distortions because some of these loads, they are also based on power electronic devices and they have front-end filters that can sink part of the high frequency distortions injected by the PV inverter. And finally, we studied the grid level propagation when we analyze how these distortions injected at the service panel of a customer, how do they propagate on the low voltage system and through the transformer into the primary grid. We found that the propagation to the primary grid is very low, as we can see here with this red crosses, which is the propagation rate to the primary side of the transformer. This is low mainly because of the impedance of the transformer and the impedance of the distribution line, which are high and attenuate the distortions. So in conclusion, this work has shown mainly that the high frequency emissions, they behave close to a voltage source on PV inverters. And in terms of propagation, we found that the propagation on the distribution system is limited due to the sinking effect of front-end filters found in power electronic based devices, and also due to the high equivalent impedance of transformers and secondary distribution lines that attenuate these distortions. So for this reason, because of these reasons, we find that the amount of high frequency distortions reaching the primary distribution system is expected to be very low. Thank you very much.